All right, welcome back. And so today I'm going to speak about the design construction sequence and the different types of views that you'll draw. And we'll do a little practice activity together. I'll show you some ways that you can, if you don't have all of your equipment, really all you should need is graph paper and a pencil, and you can get by. I am going to show you all of the techniques using the proper tools, but we'll work our way and maybe have to wiggle around a little bit, but that's okay. So within the design process, there are lots of different people at different stages who are involved pretty heavily. So a lot of times we only just really think of the architect or the designer as the person who's in the design process. But really, if you are trying to design the most efficient building, as well as a building that's pleasant to be in, then you really need to involve a lot of people ahead of time. And it's in a few slides we'll speak about that integrative design process. Because there's much more than just what is a pretty looking building or what is a building with, energy efficient materials. That can all be well and good, but if the owner isn't happy being in there or the occupants don't like being in the building, well then it really is kind of a mute point almost. Things that need to get considered when you are starting in the design is those building needs and the occupant needs. And so you need to sit down with whoever is the owner of the building or whoever is hired you to design the building and ask, what do you want? And you need to think about what do those buildings traditionally do. So if you're designing it for a hospital, or you're designing a school, or you're designing an apartment complex, there's going to be different needs coming out from different parts, and also regionally there'll be different needs. So if I was designing a building in Phoenix, I would have to have some type of air conditioning system in it. I don't think there's a single building in that city that frankly shouldn't exist in that climate. But I don't think there's any building in there that doesn't have AC. Versus here in Boone, there are plenty of places that don't have air conditioning. I don't have air conditioning in my house. I do just fine without it. So there are those different needs, as well as different budgetary needs and different building codes that are going to exist based on wherever you are doing your construction. So those are all needs to be things that are considered in the design process before you start to design the building. If you're not thinking about the budget and the needs of the occupant, then it doesn't really matter how beautiful your building is, because no one's going to want to be in it. So we draw our buildings to help explore different ideas and communicate to ourselves. That's usually the first part of the design process, is it's trying to envision something that we can't understand or it just doesn't exist yet, and get our idea out. And we're also doing it to explain and communicate to others, a different kind of an established dialogue and a conversation through that language of the drawing, to pitch that idea and get something built. If you start talking to a client with specific architectural terms, they more than likely are probably going to get confused. But if you kind of show them a drawing of this is what I had in mind, they can see it and visualize it a lot easier, and they can say either that's what I'm going for or no, I want this kind of different. And really the most important reason for creating drawings, and this is especially at our final set of construction documents, is to provide that legal definition of what this building is, what is involved in it, and what's not involved with it. So it's that legal definition of your scope of work through the drawings and the specifications. As a student, we do a lot of our drawings just kind of to observe and to learn, to understand how a typical section goes together or how a floor plan gets laid out. And the more and more we learn, the more we can kind of incorporate that into any finalized work. So as I mentioned earlier, the design process really should be an integrative process. So it should be something that lots of different people are involved with. Your building itself is this living system. There's different parts and pieces that make a building work. It's not only just the walls, but it's the lighting, it's the heating and cooling, and it really is just kind of ultimately a level of comfort that a building can provide that makes it something that people really cherish and enjoy more than just, well, this is the place I go to work. So integrative design is this comprehensive approach which brings together specialists who usually or traditionally would work separately on buildings, and brings them in together before any drawings are created to take into consideration all the different factors that would get applied when a building is constructed and then occupied. So traditionally the design process is kind of a silent, or was kind of a silent approach of, well, I'm the architect and I'm going to design the building, and you're the interior designer and so you'll deal with that. You're the contractor, you'll deal with that. And so it would kind of be then lots of things didn't really work coherently with each other. And so when you involve everyone with all of the steps of the building process very early, you then can kind of help achieve the different goals of what everyone's wanting, especially when it comes to the client themselves. Integrative design is also a huge, important part of if you have any sustainability goals. So if you are trying to reach a goal of either net zero or LEED, which is later in this presentation as well, or I think it's on the next slide actually. If that's one of your factors of something you want to incorporate into your building, then you especially need that contractor or any specialist who deals with, photovoltaics. You need to involve them in the process so you can then help design something that works well with whatever they're trying to do. And so if I wanted to do photovoltaics on my roof, it would be very wise to invite someone who is a specialist of installing them to come in and help me make sure that I'm making this roof as easy as possible for them to install, and also make those solar panels function with the highest capacity. And so using this kind of committee process, you can really create a building that is much more efficient as well as beloved. And so one thing that I'll speak about now and later on, almost towards the end of the course when we're in the BIM stuff, we'll go over some green architecture as well. I personally am not a huge fan of the term green architecture. I am a huge fan of what it stands for. But typically when people think of green architecture, and even if you Google the word when you're trying to find a nice picture to put in your presentation, all you see are just skyscrapers that are just trees frickin' everywhere. And it's green architecture because there's trees and there's vegetation on it, and it's got it has a grass roof, and oh look you're growing beets on your balcony. And okay, that's all well and good, but that's not necessarily green architecture. Slapping trees all over the roof doesn't make a building green. And so I'm more of a fan of the term for sustainable architecture and buildings that aim for sustainability. And so we'll think of sustainability too. We'll define it as something that has a positive impact on the social, economic, and environmental factors. So if it's something that's good for people, good for the planet, and also doesn't cost an arm and a leg, that's what I'll consider sustainable in the term of this course. So sustainability in green architecture really heavily focuses on that environmental factor. Primarily, the best way to really focus on it is that conservation of energy. is to reduce the amount of loads that that building is using. So if I am designing my building with sustainability in mind, I really want to try to minimize how much artificial light is used, how much water is being used, and then the heating and cooling loads that my HVAC, my heating, ventilation, air conditioning system. If I can just reduce the amount of energy and electricity my building is using, that's going to be a huge part of creating a sustainable building, and is going to do a lot more in the long run than necessarily slapping a bunch of trees on the roof. Not that there's anything wrong with doing that, but I think that's just such a small factor compared to what we should be focusing on in sustainable architecture. The materials that you use, so using recycled materials or materials that are compostable, biodegradable, ones that maybe don't have harmful chemicals in them. Particularly materials, one thing you want to try to think about too is off-gassing of things like carpets and paints. The impact it has on the environment when it comes to those materials and those energy usage, as well as that impact on occupants. And that comes from just a physical toll of, are there materials and chemicals present in that building that maybe are having a harmful physical impact? Is maybe the lighting having a impact where everything's just too bright and now I'm getting headaches? Is there kind of maybe a mental health impact of, there are no windows at all in that room anywhere, and so you're just sitting there, you don't know what time of day it is. And these are a lot of times things that come into play when we're talking about larger, kind of more public structures like office buildings and schools. But it can absolutely come into play when it comes to a residential structure, because if I'm going to be spending a majority of my time there, if it's my home, it should be somewhere that makes me feel good, both physical and mentally. It should be somewhere that I'm not feeling overly stressed. And as I said, it's not slapping plants on every available surface. And there's two big systems out there that help kind of gauge or rate sustainability in America. So one of them is the net zero standard, which net zero means if a building reaches a net zero certification, it means that it is producing as much energy as it's using. And so that's then when you can use different things like wind turbines or water or photovoltaics to help produce energy. But ultimately, when it comes to net zero, rather than just producing as much energy as you're using, in addition to that, you want to, as I said before, conserve as much energy as possible. So you want to use materials and use techniques that kind of either keep a building's envelope nice and tight, so maybe air isn't escaping, or use different passive techniques so that we can use kind of the sun to help light or heat our building. The less energy we use, then the less energy we have to offset with different renewable means. And so net zero is one of them. And then another very, very popular one is LEED certification. So LEED then takes into, I believe now it's 8 different categories where you then can get kind of graded for your building, and they grade differently based on the type of structure as well. So a school doesn't get judged the same way a house gets judged, but it's still looking at different things about how environmentally friendly is your building, as well as the indoor environmental quality. How comfortable is that building to be in? How well lit is that building? How clean is the air in that building? And so you can get LEED certification as well. But we'll go over this stuff in a little bit more detail later in the course. So the process of kind of designing and drawing is first to meet with the client and really kind of get what exactly is it that you want this building to accomplish, and what are some of the values that you hold near and dear for it. So if someone was meeting with me and they were trying to design my house, I would tell them, well, I want just a 2-bedroom, maybe a 3-bedroom house, but that some of the values that I would hold near and dear is that I hate wasted space. If there is no purpose for, if something isn't supposed to go there, then I just hate having big empty spaces. And that I do consider myself an environmentalist, so I would like to have as much passive techniques included as well. And so something that I'll be talking about a little bit in class, I often refer to the apartment or the house that I currently rent, because my landlord, when he built it, really thought about a lot of those passive things. And so I don't have, even in the winter right now, I do not actually have any heating in my apartment. I do have a little plug-in radiator that I can use. So far, I still have not had, I didn't have to use it last year at all. I still haven't had to use it. Just because of the way that the building was thought out on the site, the sun really just heats and cools for me when it just beams in through the window. So there are a lot of things that I would include then, as these are the things that I find important for my building. Other people might say, well, I have a very large family, so I want to make sure that we all have a bit comfortable. We all cook a lot, so having a big kitchen for a gathering area. These are all things that you would get from your client. And you'd gather all of that information, and you would then start to come up with different feasibility studies for different designs. Another huge important thing too, which we'll go over with site plans, is all of those schematics and feasibility plans are going to be based around the site in which the building is going to occupy. So buildings don't exist in a vacuum. Every single building has somewhere where it's being built, and you're going to know where that place is beforehand. And so you want to take that into consideration before you start designing the building. Once you kind of choose a design, then you'll start to develop it, apply for the different permits, put together those construction documents, which would then become that legal contract of what your building is going to be. You'd bid it out to different contractors, and then you would build it. So drawing itself and the process of drafting, it has existed for centuries. It started really with, carvings and little tablets, ooga booga and all that. And then it moved on to plans and blueprints. And so that was kind of, around, I suppose, the 18th or 19th century really, is really when it started to really get defined into hand-drawn blueprints. And what kind of came to be is that everyone had their own way of drawing, and it just didn't work out. To have everyone have their own way that they would describe it and define it, it had to be something that became standardized, so that this way, no matter what, everyone was going to be able to give them to the contractors, and the contractor didn't have to decipher whatever the architect meant. And so there became these standardized practices that were put together through the AIA, ANSI, and ISO. And these are still standards that we use to this day. So one thing that we'll go over next class, but you'll see some examples of it today, would be lettering. Even though we don't really do drawings by hand anymore, we still letter everything, even in our computerized drawings. And some of it is to just kind of almost put a nod to those traditions, but it's also for that clarity and for those standards. In the 1960s, we transitioned to computers and CAD doing our work. It looked a lot different than it looks today, but it still was kind of the start of using computers. And then in the 1980s is when Autodesk came out with AutoCAD, which is a software that is still used to this day, though it is kind of losing as much use, but a lot of studios and a lot of firms, they'll use a combination of AutoCAD and a BIM software, whether that be Revit or another type of software. So I know Scythe is another one that's getting kind of big. There's another one that I used as a demo, but I just didn't like it, so I can't remember what the heck it was called. But there are different ones out there. And there's even then going to be kind of a change from BIM, which is now pretty much the prevalent standard, towards other types. So what there's a picture on the side is just an augmented reality piece of software where you have the drawing printed out and it can show you then the 3D model of the building. And I think there's going to be even more of a push. In my opinion, I think that's where kind of architecture and interior design is going, towards that augmented reality side. Which, if you're unfamiliar with what augmented reality is, it's essentially the same, it's your Snapchat filters. That's exactly what augmented reality is. And so IKEA has an app so you can test out different furniture in your home before you go out and buy it. You can see if it fits and everything. I saw a video, but I can't find it for the life of me because I don't remember what the product was called. But it was an augmented reality for construction, where you could hold up a tablet or a phone and it would show you then what like the wall frame would look like there. So you could just kind of check the work and everything. And that's where I think everything's going to get pushed to. And then eventually that'll get phased out and some new thing will come in. It's always changing. So originally drafting started as a hand drawing career or craft. And now hand drawing, when it comes to technical, finished, complete work, it's not really used anymore. I'm not saying that there aren't architects out there or designers out there who no one hand draws anymore, but it is kind of becoming something that you're seeing a lot less of. Or it is something you see a lot less of, not becoming. But it's still an important technique to understand, especially as just kind of a tool to observe and explore. Now, the other tidbit with that is that the area of industry you're working in is going to matter with how much hand drawing is done and to kind of what effect it's done at. So from what I've seen, interior designers still do a lot more hand drawing, even when it comes to kind of finalized designs, than architects do. And that's because maybe you are trying to show specific furniture or specific cabinetry details, and you can't necessarily find the files for it because they don't exist. Or maybe it's even something that's completely custom, so you'll never find it online because it doesn't exist at all. And so they'll use hand drawing a little bit more, but it's still kind of just something to kind of explore and ideate before you get to your finalized version. Hand drawings have also been kind of intention grabbers and convincing pieces. So if you were submitting a project for either a competition or maybe just to put a bid down, they tend to be a little bit more attention grabbing than just a computerized drawing or a rendering. In my opinion, and once again, this is just an opinion, but in my opinion, computer renderings, the first time I saw one, it was the coolest thing I had ever seen. And now a Revit rendering is just a dime a dozen. They all, they just kind of look the same, and so they don't really grab attention like kind of a really nice hand drawing done with and, you know, markered with all of the different textures and colors can really kind of just make you look at it and appreciate it a little bit more. So with that being said, after we kind of used hand drawing as our technical side, and now it's kind of just more of our creative side, a lot of technical stuff then is done with computerized drawings. Particularly AutoCAD is what we're going to highlight, but there are different softwares out there. And you can also hear this referred to as computer-aided drafting, or computer-assisted drafting, or computer-assisted design. It all is the same thing. What makes CAD so fantastic is that you can do so many things with it. So AutoCAD is not just for architectural drawings. You can use it for any type of technical work. So if I was doing something for a machine shop, and so that's where my original drafting start was, in a machine shop, doing tool design for surgical equipment. Like AutoCAD was still what I used. And it can do so many different things, and if I need to make any changes or adjustments, I can do that very easily. So what I would think of is, if I was a architect and I gave the set of plans for a client to look at and they told me that they wanted the kitchen, or let's say it was this set of plans and they just want this wing extended to have another set of, I guess workspaces, or maybe this is a hotel, it looks like a hotel. So another extra 4, hotel rooms over here or whatever. I could do that hand drawing, but then I would have to do it for the floor plan, do it for the foundation plan, and then also do it for my side views and my elevations. So I essentially now have to change, if I already had done the mechanical and electrical and plumbing plans, I now have to change about 10 different drawings, and it's very easy for them to get out of sync or for mistakes to be made. So with AutoCAD, I then can kind of just go and copy and make all those changes, and with a lot less effort. And I can easily just kind of reuse things and adjust things if I need to. My recommendation when it comes to CAD work versus hand drawing is to choose the right tools for the task at hand. So it depends what you are being asked to do and how much time is it really going to take to set it up on the computer versus to just do it by hand. And then especially when we move on to BIM too, it's kind of, some things are still just easier and better equipped for doing just as a 2-dimensional AutoCAD drawing of just placing lines down versus doing it all in BIM. You also, of course, then with the computer, you have much cleaner line work. You don't have to worry about pencil smudges or making erasings and like getting your eraser shavings off the page. The kind of caveat, I guess, to CAD would be is that you are limited by the person using it. So if the person using it doesn't really have a good skill set behind them, doesn't really understand the software, just isn't doing too great with it, doesn't take the time to really understand all the different parts or pieces to it. And that's also outside of classes too, so I definitely was not taught everything I know about AutoCAD in just the courses I took in schools. There is a lot that I learned through just my own practices and then trying to do something and not knowing how to do it and then finding it out on my own. And I learned something new about AutoCAD at least 5 things a year. Sometimes it's more. I've gotten to a point now where I've spent more than half of my life using the software, so I've learned quite a bit. And they've stopped putting out a lot of big new features to it too, because AutoCAD is getting phased out by Inventor if you're doing 3D modeling, or Revit if you're doing architecture. But you're still, the more you use it and the more you practice it, the better you become on it, just like anything else in life. And so there's now been this shift towards what's called Building Information Modeling, or BIM. So BIM is the, I want to say, new kid on the block, but it really gained its prevalence in like 2008-ish. It existed before then, but that's really when it kind of picked up. So it's not really all that new on the block. But it's a 3D parametric model of your building. And so parametric means that there are different parameters or different requirements set to the building of what it's doing, and then it creates these linked two-dimensional views related to that model. So as you make the 3D model of the structure itself, it then creates the floor plan, it creates the sides or the elevations, it creates the section views. It makes all of that for you. And so what could easily get out of sync in AutoCAD, and so remember, if I had to add on 4 more rooms over here, well, and I have to then update all of the side views, the foundation, the electrical, all of those, it could be easy for me to forget to update one of those views. Well, with a BIM model, everything's done automatically. So if I make a change in the floor plan, it updates the whole 3D model and changes any of those other related views. Excuse me, I had to sneeze. And so the real kicker, and in my opinion, what makes it the real nail in the coffin for traditional 2D CAD, is that information part of the building information modeling. And so BIM as a whole is the process of all of the parties involved in the construction and life cycle of a building, sharing data. And so all of that information gathered from the concept of the building to the completion isn't just necessarily stored, but it's something that can be acted upon. And so in that model, you have where the walls are, but you also have every material that's included in that wall. And you have all of the windows down to an information file that says what type of glass it is, what type of plastic the frame is made out of, how much each one of those windows cost, the energy efficiency of all of the materials. All of that information is stored in that BIM file. So you have all of those R values associated with all of your materials. You have the life cycle information about it, so you know kind of maybe when different things have to get replaced within it. And so you have those architecture capabilities, but you also then have engineering associated with it. So you can, with your model done properly, you can then figure out how much energy would be used by lights based on a set schedule, because you can also then put a solar analysis plan. So you can say, well, the lights really only need to get used from 6 p.m. to 9 p.m. and so therefore we can figure out how much energy would get used through lighting. And you can do based on the materials you chose for the walls and windows. You can associate how much would it take to heat and cool that building. And so you can use that information in there. And so BIM is sometimes thought more of just like more of a 3D thing. You can put 4D in there as well if you're thinking about the time, because you can also put in how long would the project be to complete. And then you really have that 5th dimension of linking those different components and schedules and costs and life cycle analysis information all within the building. And you can just get so much information to really understand that building better than you ever could before. And that's before it ever even gets constructed. You can get all of that information gathered and tested. And then you can also run, you can compare how much you thought it was going to be versus how much it is. And the more information you gather from that, the more accurate your estimates can be. It's a really cool, wonderful thing BIM can do. Unfortunately, we're not going to get into a lot of those kind of component and energy analysis things in this course. I'll show you how to just do one quickly. But there is an advanced class in the graduate school that I think would be great for those of you who wanted to do that one. So yeah, we have all of those different graphics, all of those different methods we can use, but they all come down to kind of ultimately in the set of construction documents to explain the same thing. And so we do that through almost a different language of drafting, and we have different conventions or different standards that we have to follow. But there's also kind of different dialects or abbreviations of different graphical patterns. So maybe rather than saying that this is concrete, I'll just use kind of a pattern that represents that this is concrete. Different abbreviations for construction methods. And our lines are showing what goes where in our building. And then our notes are additional to help explain the how and the why a building gets formed together. And so it kind of all starts to come together from an initial, what is often referred to as kind of just a bubble sketch of just trying to figure out where things may go, where different rooms are located, to then a little bit more of a refined sketch, and then a finalized version of construction plans. There are different ways that we can draw. So we have 2D and we have 3D methods. Without understanding the almost the language of different lines and patterns and symbols, everything about the design and construction industry is more difficult. And so that's why a lot of this course is going to be focused on what those different lines mean and what they entail, what different patterns mean and what we entail. And all of our next lecture, or most of our next lecture, is going to be dedicated to those different lines and those different patterns and what they kind of mean in there. Patterns are often used for our different materials. Symbols are used to show where parts are located and how they can join together. And all together they describe these different methods of assembly. So it's often not spoken directly out loud, but you can infer it through those different symbols, patterns, and shapes that are shown. And it takes practice to be able to look at a drawing and know right away what system's being described, or to look at or to know the general look and outline of each system connection. This is often described through what we call a section view, which we'll look at in a moment, which is a very critical piece of that puzzle in construction. And we also have, I believe, 2 days in the schedule just purely dedicated to sections because they're that important. Maybe not. Yes, so we have 1 day of sections and then another day of making sections in AutoCAD. They're that important, kids. And now there are different methods we can explain all the different parts of a building in. And so we have kind of what is considered our 2D method, which would be orthographics, and then different 3D style drawings, which would be our isometrics, our obliques, and our perspectives. Now, when we're thinking about making a set of drawings, we need to think of what is called the plane of projection. And so the plane of projection is the surface that our graphic is kind of projected, for lack of a better word, projected onto. And so it's our 3D object into its 2D equivalent. Now, if we're speaking of orthographics, our sides of our object are parallel to those planes of projection. So when I'm looking at a floor plan, I'm looking directly down on that building. Or when I'm looking at an elevation, I'm looking directly at one of the sides. So the drawing itself is parallel to the object or to the plane of projection. If we're doing a 3-dimensional object, then it is going to be related to, or a three-dimensional drawing, it is related to our object in a plane that isn't parallel, and depending on what type we're doing is going to depend on where that plane of projection lies, but I don't want to go over that too much, because then I'll just start to overly confuse you guys. So orthographics are one of the most traditional styles of technical drawings. It's one of the most important when it comes to manufacturing, because this is then what you would be sending the manufacturer to create. But in orthographic, as I said, it's parallel to the planes of projection, and it's showing several sides of an object in one drawing. So it isn't one singular view, it's several views to help tell the entire story. Traditionally, it is 3 views. So traditionally, it's our front, our top, and then a single side view. We can unfold an object to show 6 views in total. So all objects have a front, a back, a right, a left, a top, and a bottom. So you can show 6 different sides of something, but traditionally we just only show 3. And that's often because you just get repeated information from other views. So for instance, with this chair, I don't really get any extra information from this side view, so I kind of don't need to have it there. Where we use orthographics in architecture is in all of our plan views and our elevation views, or our side views of our building. So our floor plan is taken directly from head-on. Our front elevation is taken directly from the front, or our sides are directly from there. So it's always parallel to the plane, and each view can only tell me 2 different dimensions. So all objects have 3 different dimensions to them. They all have a width or length, depending on how you want to define it, but they all have a width, a depth, and a height. And within each orthographic view, we only get 2 of those dimensions. So within our front view, I only have my width and my height. Within a side view, I only have my depth and my height. And within a top view, I can only get my width and my depth. So depending on which view you have, you only get those 2 dimensions, and that's why you need at least more than one drawing or more than one view to tell the story fully. A section view is a style, I guess, of orthographic. Once again, kind of just to define it a bit easier. So it's still from a section view. We're still taking it directly head on. We're still missing one of our 3 dimensions. So in this case, I can't see the depth of this building. But it's essentially cutting our building open, or cutting our object open, to look at the interior details, to help understand how something's getting assembled, or what construction methods are being used, what materials are being used for framing, and things like that. So any details that wouldn't be just visible from the outside, we would see in a section. So we use them heavily for understanding construction details. There'll be several section views in a set of drawings to help kind of zoom in on different areas. In kind of traditional manufacturing, you'll see sections used a lot for assemblies as well. So easiest example to think of would be like if it was a car engine. There's way too much going on for me to try to explain it all in just the top, front, and side. And so I could use this section then to kind of help understand a bit more how it gets assembled and how it works. Isometrics are giving equal emphasis to all of the different faces in there. So this is a 3D style drawing in which all of our different axes are equally split. And so if I have an X, Y, and Z, all 3 of these faces, so this would be my XZ face, my YZ face, oh wait, no, sorry, this is my XZ, and this is my XY, and this is my YZ. All three of my faces are getting equal emphasis in that particular drawing. Our vertical lines remain vertical in this style drawing, and our horizontal lines, if they are parallel to the plane of projection, are at 30 degrees. And so we can see in this example here of this staircase that there are some lines that are not necessarily at 30 degrees, and that's just because they wouldn't be, if this is a set of stairs, they're not sitting flat against that plane. So they are being drawn at an angle. I don't know exactly what the angle is, but I do know where the stairs stop, or where they start and where they stop, and so I could project out at 30 degrees, up vertically at 90 degrees, and kind of just connect the dots. And I'll show you some practice examples of that in a few minutes. So isometrics tend to seem kind of out of proportion because this isn't how I would ever traditionally be able to view something. I can't view it from this angle unless it was floating in kind of an abyss. But it is the easiest way to see see three of the predominant sides of an object to kind of help understand how it goes together. So isometrics are used in exploded assemblies, or even just plain assemblies in like manufacturing style if it's not an exploded one. But we use them a lot in architecture to help understand plumbing layouts or mechanical like HVAC systems. We may see as an isometric style drawing along with its plan or orthographic view. And in the field of manufacturing, we use isometrics pretty heavily to just kind of, along with the orthographic, to just show this is three-dimensionally what that final version looks like. Obliques are another style of 3D pictorial, not really used as often as like the isometric or the perspective that we'll look at in a moment. So with an oblique, your object is an irregular shape with the most irregular surface, or the surface that has the most detail, that is flat against the plane of projection. And so what I mean by that is this is what we would call a plan oblique. So all of these smaller little details related to like the roof and everything, it's parallel to the plane of projection, so it's still sitting kind of flat against the top view. This down here is what we would call an elevation oblique, and so our elevation, or our side view of our house, is parallel to where we're drawing, and then we project back at an angle. So this is going to show your view distorted, but still kind of help define it three-dimensionally a little bit more. There are, along with the fact that we have our plan and our elevation obliques, and we'll also practice that a little bit today too, there are kind of two different definitions of how you can define that depth. So you can do what's called a cabinet oblique, which is where you go back half of the amount of depth. So if your building was 20 feet in depth, you would just draw it as 10 feet to kind of help account for that distortion a little bit. Or a cavalier, which you would do full depth. And so in a plan oblique, your depth would be the height of the building. So this depth then would be the heights coming up. And then in a elevation oblique, your depth is your building going back. And then kind of finally, the perspective style of drawing, which accounts for the natural optical distortion, I guess we could call it, for the fact that things get smaller as they get further away from you. So this is a very traditional way that we can kind of think of drawing, and I'm sure all of you guys, if you had an art class in high school or in middle school, did at least a couple of boxes where you did them in perspective. And so things get smaller as they get further away from you, the viewer. There's two traditional types that we'll at least practice in this class. One is a 1 point and a 2 point, and that refers to the vanishing points that are sitting on what we call the horizon line. And so in this instance, we would have a horizon line going all the way across here, and this would be a 2 point perspective because it's going towards a vanishing point on the left and another vanishing point on the right. A 1 point perspective only has a singular vanishing point, and it's typically in the middle of the drawing where all of your different points converge to. So it's very typical for architectural style drawings, if it's a 1.1, a 1 point perspective, for that vanishing point to be directly in the kind of the center of the drawing. So how do you decide what type of drawing to do? Whether you're doing an orthographic, an oblique, perspective, isometric, how do you decide which one to use? And it depends on what you are trying to explain. So if you are trying to make a set of construction documents, well, you would do your plans as orthographics. If you were trying to pitch an idea to a client, you may have an isometric involved, or you may have perspectives included. And also computerized renderings, so like the renderings done in BIM, like that one picture I showed on the couple of slides back, that is a perspective. So all of renderings that are done on the computer are done with perspective methods as well. But if you're trying to pitch an idea to a client, then you'd probably have perspectives or renderings involved, or maybe an isometric. If you are presenting for a client or for a competition, once again, you'd probably have some perspectives in there and maybe an isometric or two to show like an exploded construction assembly. If you're trying to better understand it for yourself, maybe like a section view would be helpful, or even a perspective section or an isometric section. So one of the sections I showed on that slide about them, it was kind of a combination of the two of them. The thing to keep in mind is that a single project is never done with just only one view type. It's not just orthographics and that's it. It's not just an isometric and that's it. You're going to have several different types of drawings included in a set of plans for a project. Now, let's move on to some guided practice. So, I did notice in the last video I did, my like FPS was really low. So like everything was like super laggy. I looked like I was moving, like I was the Flash. And so my apologies about that, but I'll try to at least move my arms a little bit slower. Let me just get a chair as I do these practices, so that way it's not me flying across the page. So I'm going to do these, as I said, I'm going to do them using the traditional tools. So like I am going to use my T-square and my set squares and all that jazz, but I'm also going to do it with graph paper underneath my tracing paper. So this way you can see that if you don't have a T-square available or anything else, you still can complete these drawings. And so really all you would need is graph paper, a pencil, and some type of straight edge or ruler. Tracing paper or some type of tracing paper then would only help more. So just for my sake and to make this a little bit easier for me, I'm going to make sure my graph paper is getting taped down nice and straight. And so I'm just lining up in one of the lines of the graph with the edge of my T-square. and then taking some tape and taping down the corners of the graph paper. If all you have is graph paper and you don't have any tracing paper or anything, well then you'll probably just need more than one sheet of graph paper, and then maybe don't tape it down. So the reason why we tape our page down is so then I can just move my T-square up and down and just be able to lay lines out and know that all of these lines are going to stay nice and parallel to each other because the page itself can't move. Now what I'll do for my practices is I'm just going to tape a sheet of tracing paper on top of that, so that way I can just keep using the same sheet of graph paper. Because there's no line work or anything on my tracing paper, I'm going to tape based on the edge of the sheet. But if my sheet has any line work on it, whether it just be like kind of from an existing template, or maybe it's a drawing that I had untaped and I was retaping, I'd want to make sure that I'm taping based on that line work. And that's just because edges of pages can get frayed, or maybe I didn't tape it perfectly the last time around. Whatever it is, I just want to make sure that my lines are going to stay parallel and perpendicular no matter what. So now I'm ready to go. And like I said, if you don't have a T-square and a set square like I do, you could just do this all by just kind of drawing the lines based on your graph paper, as long as you're using something as like a freehand tool. But I have all of that stuff. So let's get rolling. So for this first practice, I'm going to create an orthographic of this object. And I've got some measurements down for it as well. If you wanted to draw it like at half size too, or half scale, feel free to half these. What I'm more concerned is that you understand the process of making the drawing and how the different views of the orthographic correlate to the object. Not necessarily that you knew how to read a ruler, because you probably learned that in kindergarten. So what I've been given here, so this is an isometric view of this. So it's an isometric, so if I drew a horizontal line across, I've got the same angle here. I've got a 30-degree angle, so I've been given an isometric and I want to make an orthographic. So all objects have those three main dimensions. And so I've got my width, my height, and my depth. Now, with orthographic standards, and this doesn't apply too much, this doesn't really apply to architectural drawings, but I do know that some of you, especially the sustainable tech majors, you may be dealing with things other than architecture. The way we traditionally lay our views out in an orthographic is what we call third angle projection, in which we have our front, our top, and our side. The important part of this layout is also that we have alignment of views, so that this edge of my top view is aligned with the same edge of my front view. Edges are aligned, aligned, aligned. And there's a special technique to help make spacing and that alignment a lot easier. And so I'll kind of demo that for you guys, but also, once again, if you just kind of trace around the boxes, you can get it done that way too. Okay, so the first step would be to define which view is my front. So I'm going to make this one my front. And to just sketch out my front based on its 2 dimensions. So my front gives me my width and my height. My top view gives me my width and my depth. And my side view gives me my height and my depth. So based on the information I have for my front view, I'm going to use what's called the bounding box technique, where I'm just going to draw an overall box. If this thing was essentially a big old slab of marble, and there was just a whole big box in it, just what are my overall dimensions for my front? And so it has an overall width of 6 and an overall height of 4. And so just kind of picking somewhere in the bottom to start, I'm just going to draw a light guideline out. And then I'm going to use one of my triangles to draw a guideline up. So I'm right-handed, and that's why I draw with my T-square being held with my left hand. As I use the T-square, I'm pushing it in against the board. So I'm just kind of tugging at it with my fingers a little bit. And then I've got my set square with some of my fingers, and I'm pulling that down. So I'm making sure that this is always staying flat against here, and I'm making sure this is always staying flat against here. So it's kind of an important thing to remember to help make sure that you're keeping all your lines perpendicular and parallel. The reason why I drew these out so far is because it'll help me just keep everything aligned. So I know this is way longer than 6, but it'll help me when I'm drawing my side view. I'll already have kind of a guide given of where the bottom of my side view is. And the same thing then with my top. So for my side view, I have a length of 6 inches. So I'm just going to measure 6, and I'm just going to make a little mark. And then I'll measure up 4 and make a little mark. And with my T-square, I'll just draw a very light guide out. I'm drawing maybe a little bit darker than I would recommend you draw your guidelines, but that's just because I want to make sure they get picked up by camera. And then I'm just going to draw a guideline up. And so this right here is the overall bounding box of my front view. So within my front view, I have this scenario here in that I have a line that isn't perfectly parallel perpendicular. It's not a perfectly vertical, perfectly horizontal line. And that's okay. What instead I would do then is I'd be able to figure out where it starts and where it ends and just kind of work my way out from there. So I know that on the top it goes in 2 inches. So I'll grab my ruler. I'll measure in 2 and make a mark. And then I can tell that it goes, I'll move that over a little bit. I can tell that it goes up 2 inches. And so I'll grab my ruler, make a little mark. And now I know where that slant starts and where it ends. And so I can just take a ruler or a straight edge of some sort and connect the dots. And I'm going to leave this corner up here. I have a reason for it. And so I have just the front view of my object drawn. So if I was looking at this object from the front, I wouldn't be able to see how far back this face goes at all, but I would be able to see what its width and its height is. And I'll just go and darken that. Oops, would help if I didn't move my ruler. Okay, so next then would be to do my top view. For my top, I'm just going to establish a distance that I want between, a break I want between the front and the top, which I'm just going to make a random amount, and I'm just going to draw a guideline all the way out. So this corner right here is the same as this corner right here. It's also, this corner here is also this corner here. And so that's why I want these to be lined up with each other. Now, I don't have to take any measurement related to the width because I already have that guideline projected up from my front. So from my front view, I already have a guideline that's projecting all the way up, and so I already have something that tells me that it has an overall length of 6. What I need to instead is to draw it with a depth of 1. So I'm just going to lay my ruler out, make a little mark at 1, put my t-square against it, and I'm always making sure I'm putting tension against my t-square as I use it, so I'm always kind of pulling at it. Draw a line across, and now I have the overall bounding box of my top view. Now pretty much any time we have a feature or any change in measurement in our front view, we need to make sure it's also shown in our top. So this needs to be shown as different from this. And so I'm just going to take my t-square and set square, line it up, and just project that up. Now, with our top view, we are unable to see how far like this slopes, because that slope downwards is related to its height, and our top view doesn't tell us height. Our top view only tells us width and depth. So I can't see it sloping downward in the top view. I can see that there's a difference between here and here, but I can't necessarily see how far that slope goes. So the way I try to describe that a bit further is if I was looking at like a theme park from like Google Maps and I was looking down above it, you can't necessarily see how far down the roller coaster dips, but you can still see the roller coaster like as it slopes, but you can't see what the slope is. I didn't word that correctly, but hopefully the idea makes sense, and if not, let me know and I'll try to think of a better way. So now I have my front view, or my front view and my top view done. And I'll just erase some of the kind of guidelines around it. So finally, for an orthographic then, I would need to define what we call the side view. And what I could do to help me make sure that I'm maintaining proper spacing in my views is I could measure how much space I used over here, put it over here, and start projecting everything. But the faster and more technically correct way is to use what's called a miter line. And the miter line gets its name from the miter joint. So if any of you guys are woodworkers, a miter joint is a 45-degree joint. And so I'm going to use my 45-degree angle. So just putting it flat up against my t-square. And I'm going to project 45 degrees out. So we make our miter line we make it where the top and right side of the front view meet. So even though this isn't on my object at all, that's still where I would project my 45-degree line out. Oftentimes our miter line does sit directly on the side of our object, but in this case it doesn't, because it has this kind of just gap up here. So I project up at 45 degrees, and then where my projected guidelines come out from my top view, I'm going to project down. and I'll make sure to send it out to, and if I don't, please harass me about it, is I have lots of orthographic demo drawings of different objects, so I can send you guys of different ones as well. And then I'll just need to make sure that I project this guideline over. And just like with our top view, we can't see the slope necessarily, but we can see that there's a difference between this face and this face. And then I would erase all of my guidelines. And so another thing I really like about vellum paper is that it is very easy to erase on. And so even though it smudges, like, you can get rid of the smudges really easily. And so then I have this shape drawn as an orthographic. And so I have my front, my top, and my side. With just the front view, I have no idea what that depth is or how far back that goes, so that's why I need more than one view to completely describe this object. Okay. Next up, I'll untape that. And I'll leave my graph paper taped because it can help with some of the obliques, but it's not going to help too much with the 3D ones. So you can buy, and let me go get it just to show you. So hold on. Sorry about that. So this is isometric graph paper. I'll move the camera down a little bit so we can see it a bit more. And maybe we can't see it, and then this was just a waste of time. But so this is just graph paper that has 30-degree angles on it. So instead of just being like a traditional graph paper like boxes, it has little 30-degree angles to help make isometrics a little bit easier. Honestly, especially if this is just a class that you're just taking for like a major requirement for construction management or sustainable tech, don't go spend your money on this. What I've seen students do in the past that works pretty well is they'll just search for isometric graph paper for on their computer, and then they'll just trace over it or print out like a sheet of it. So I wouldn't really recommend going to buy it, but it's just kind of a little thing that you could use. But anyhow, so for the next practices, we're going to make isometrics, an isometric, a plan oblique, an elevation oblique, and a perspective, all for this same object. And so there are no dimensions, so we're just going to kind of focus on the overall form of it rather than any particular sizes. One thing to just kind of mention, since we haven't gone over the alphabet of lines, is there's this little dashed line over here, and that refers to a hidden edge. And what that dashed line is referring to is this this edge that's going on straight down the middle in there. So if I was looking at this block from the side, if it was a solid piece of wood, I wouldn't be able to see that edge that's going through it. And so that's why we would show it with that dash line to help communicate that something is going on there, it's just not visible in this particular view. We'll go over that a little bit more on Wednesday, but I just kind of wanted to clarify it for now. So we'll start off with an isometric. and I'll get another sheet of tracing paper that I'll just tape down nice and straight. And so I'm going to do this once again using the tools of the T-square and one of my triangles. And if you don't have them, that is okay. Just try to freehand sketch it to the best of your abilities, that you are keeping an equal emphasis on all of your sides. And so if you do have a T-square and some triangles, the one that you're going to want to use is the 3060, or what I sometimes refer to as the long skinny one. And so this one, along with our T-square, can be used to make 30-degree angles. So very much like the orthographic, the first thing I do when creating an isometric is I create an overall bounding box, and then I use a subtractive method to just kind of carve away the different pieces. And so if I was to draw just an overall box around this whole thing, it would just be kind of like a rectangle, a rectangular prism that's a little bit longer, or I guess twice or maybe 3 times longer on this side than it is in this way. So I'm going to make a rectangular prism, and I'm going to try my best to just keep all of my lines parallel where they're supposed to be. And so while I'm using a 30-degree angle, so this is definitely not going to be perpendicular, this line for this edge is going to be parallel with this line, going to be parallel with this line. The same thing with these ones, parallel, parallel, parallel. And then all of my vertical lines will be parallel with each other. So because I have the tools like the T-square and the triangle, it's going to be a lot easier to keep everything that way. If you're doing it with hand sketching, just try your best. So to just create my overall bounding box, I'm going to use a 30-degree triangle, and I'm just going to put a guideline out that way, flip it around, guideline out this way. There was no need to flip it that time, but I just like to use the longer edge. A guideline up. So this is kind of like my X, my Z, and my Y. A lot of times some software they do an X and a Y, and then they make the vertical, the height would be Z. I define it using Minecraft coordinates, so this would be my Y, but you know what? Do whatever makes you happy. And so now that I have kind of just this right here, would be the same if we're looking at our object. It would be this front bottom corner. And so I'm just going to pick a length and just project for the rest of my front. Same thing over on the side. I'm just going to kind of choose a depth. Since I don't have any dimensions, I'm just kind of freehanding it a bit. And then I'll pick a height that I want my object to be. So I'll say that's how tall it is. And so I'll project out at 30 degrees. Flip my triangle over. Project out at 30 degrees. And then where it crosses our established depth and width, we'll just project parallel lines. So I'm just making, based off of the shape, I'm just making a rectangular prism. That then gives equal emphasis to my front my top and my side view. Next then is I would go and carve out the rest of the features. So I always start then with carving out like the front face on here. And so for the front face, I can see that it goes over a little bit on this edge. So I'll just go, you know, that much over. I'm not taking any measurements. And then I'm going to just do the same amount on this edge. So I'm going to use a very, very, very technical technique of putting 2 fingers there, picking it up and trying not to move my fingers too much. Say it's about that much. Some tools, if you wanna waste money on more tools. So something you could get is so this is a divider, and so it's just a compass with 2 pointy ends instead of a pencil in one of them, and it stays pretty stiff when you move it. And so I can just take the measurement from here and transfer it over here. Oh look, I was so good. Or you could do it with a compass too. You could just set your compass to whatever it is and then just make a little mark. So this is just kind of used to easily transfer dimensions from one to another. If you wanted to just spend money on more drafting equipment. So I have kind of these 2 ledges marked out, and because they just go straight back, I'm going to use my 30 triangle and just go straight back, straight back. Now, in my front view as well, I go down and over, but not necessarily directly down and over. So because this is what we call a non-isometric line, since it has that angle to it, I'm going to just project straight down, project over at 30 degrees until I find exactly where I would want that point to be. Now my drawing is going to look a little bit wonky, just because I probably should have either gone longer with the length or not put these as far out, but it'll get the concept across. So like I said, I'm just going to put a guideline straight down, and then once I figure out how far down I want it to go, I'm going to go over. So I'm going to try to pick where the middle of this would be by just eyeballing it. So I'll say that's the middle. And so then that would be my point. And instead of doing this at a 30-degree angle, I'm just going to kind of connect the dots. So it's not perfect because I don't have any measurements, but it's okay. Now, the same thing is I'm going to project this back, project this edge down, and over, and I'll find where those 2 would meet, and then connect the dots. So with an isometric technique, you're still dealing with lots of parallel lines, especially like you are with an orthographic. But the main difference with an isometric is that you don't have perpendicular lines to each other. So all of your vertical lines would remain vertical, like they look in the orthographic. All of your horizontal lines are at 30 degrees. And if lines aren't parallel or perpendicular in the ortho, you can still find where they may end up by just carving out how far down, how far over. And so that would then be that shape as an isometric. Now, if I was doing it as a plan oblique, and I'll do the plan oblique and elevation oblique on the same sheet. Got eraser shavings everywhere. See, so this is what I mean about not buying drafting dots, because you'll go through those so fast, and they're just kind of overpriced in my opinion. And also, if you guys can hear that annoying little whirring, I apologize, but I got a 3D printer going, so it's just going all the dude all day. Or maybe the mic doesn't pick it up, and then who cares? But anywho, plan obliques. So with a plan oblique, I am going to once again use my 30-60 triangle, but instead of giving equal emphasis, what I do for a plan oblique is I'm going to go 60 degrees in one direction, 30 degrees in the other one, and then directly up. So this still then is going to be my X, Y, and Z coordinate, but it's just kind of taking your orthographic that was laying flat this way and pushing it up to kind of give an emphasis to that height. So still, and I'm going to do this actually a little further down on the sheet. Now, you know what, I can fit it. I can fit it. I can't fit it on the graph paper, but I can fit it on the rest of this here. So I'm still going to once again just start with an overall bounding box. And so I'm going to establish a depth. This T-square is like, this plastic one I got is a real piece of junk. It keeps lifting up off the edge. Isn't great because then my set square splits underneath it. So I'm just going to once again establish just an overall bounding box. And I'll say that that's my height. Why not? And so I'm still following parallel lines that are parallel, parallel lines that are parallel, but it's just utilizing two different angles. And so I start with an overall bounding box of the object, and then I can use that subtractive method to cut away at different parts. So again, I'll just take from my top view about how far over do I want that edge to be. I'll transfer that same distance over here. And so I'm just kind of guesstimating. I did a little bit less over here. You know what, I'll move this one. And so if you don't have, again, if you don't have the T-square and the set square, you're just going to try to freehand it where you're going 30 degrees in this direction and then just at a steeper angle in this direction. So you're just kind of starting off with one angle that's pretty steep and one angle that's a lower slope, and just try your best from there. So I just want to switch this because I made the other, I didn't make a match really, and it was going to bug me. There they go, they match better now. And so if I've got those ledges established, I can still just like with the isometric, I can say, well, how far down do I want it to go? And how far over do I want it? How far down? And we'll say that that's where that point sits, because I can make that point about middle. And so then it's just a game of connect the dots. So with your plan oblique, you have kind of that emphasis of being able to see the details of that top part, but as you can kind of see, you are getting some distortion involved with the object itself. And I'll just darken it. And just like with the isometric, if lines aren't parallel or perpendicular as they would be in the ortho, then it's just a game of how far down, how far over. Now, for an oblique perspective, you do draw the front face exactly how you would see it in an orthographic. So this is where your graph paper could come in handy. So you draw your front face as it appears in orthographic. And so elevation is just the fancy architecture term for like the side views of your house. And so I'm just going to draw exactly what I see on here, over here. And so I'll say it's about 4 boxes over, 4 boxes over, and we'll say it goes right there. So I'm just kind of establishing where this slope goes to. So I'm just measuring how far down, how far over. Since this isn't a line at any direct angle, actually I think it's at a 45-degree angle, but we don't know that for certain because we weren't given any measurements. So I just start with an overall bounding box. It's kind of how I start every drawing I've ever done, even often in CAD, especially if I'm doing 3D modeling in CAD work. Now if I'm doing in Revit, I don't use this software or this process. But if I'm doing a 3D model of something in AutoCAD, or even in architectural drawing in AutoCAD, but I mostly use things like AutoCAD and Inventor to do 3D modeling of work. I start with just an overall box and I kind of chip away at it like it's almost like it's a piece of marble. So I just start with my orthographic view, and then you can project back really at any angle. So you could do it at 30 degrees, you could do it at 60 degrees, you could do it at 45, as long as you're just consistent with your angle. So I'm going to do a 30-degree angle. Some of you, if you don't, especially if you don't have your tools and you're just using graph paper, you probably want a 45 would be easiest for you, because then you could just go from corner to corner of the boxes. But I'm just going to project back at 30 degrees for me from just all of these corners. So now the only reason I skipped this one, this down part here, is because I knew that if I projected it back, it's just going to be sitting hidden behind like the front. So that's why I didn't project it. Well, actually, though, I'm going to need to, though. Anyway, so Good thing I went and added it. And so I'll just connect, and so I'm just kind of picking a depth since I don't have any measurements. I'm just saying that it's about that much. And then I would need to figure out how far back here. So let's see, I went about 1, 2, 3, 4. It's about there. That's where it would meet. And so with a elevation oblique, your front face is drawn almost like an orthographic. Let me use a better eraser. Or exactly like an orthographic. And then you project back at a given angle. So you're looking directly head on at the front or at the side. Versus this, you are at an angle, but you're almost looking directly down from the top. Now, for the last guided practice, we'll do a perspective of that object. And I'll do a 2-point perspective of it. Do I not have any more tracing paper or graph paper? Tell you what. I'll just do it over here on the side of this isometric since I did not cut out enough sheets. It's fine. We'll improvise. So I'll do a 2-point perspective of this. You could do a 1-point if you wanted to, but I'll just show you a 2-point one just because it's a little bit, I guess, more complicated. There's my tape. Tape down all my corners. Okay, so the first part of a perspective drawing would be to establish a horizon line. And then on that horizon line, you will choose where your vanishing point or points are going to be. So I'm just going to put one vanishing point over here and one here. So this is going to be my vanishing point number 1 and my vanishing point number 2. So in one moment, I got to sharpen my pencil. Okay. So for a perspective, there are a couple of different ways you could draw it based on the horizon line and vanishing points. You could do what's called a worm's eye view. And so if you draw above the horizon line, so if I had my cube drawn up here, if I just was drawing a cube, this would be called a worm's eye view because we're able to look at the bottom of it. And if you draw your object below the horizon line, so if I draw about the same thing, that one got a little messed up, but so this is called a bird's eye because I'm looking down on the object and I can see the top. So if I was just setting a perspective up with just like a box like I've done here, just as kind of like a freehand sketch, is I essentially establish a front corner and then at whatever height I need it to be at, and then I just project to that vanishing point. And so what I was doing was just kind of freehanding it by just looking at where that vanishing point would be. Oftentimes I'll just kind of trace the line without putting my pencil to paper, just to kind of see that they would be lined up, and then I'll just go and do my freehand sketch work. It takes practice to do that, but there's nothing superhuman about me that makes me capable of doing that you couldn't. And so you project one edge towards vanishing point 2. You project the other edge towards vanishing point 1. And so again, when I project these, I do not bring the line all the way towards the vanishing point, like you may see some video tutorials do. And that's just because for me, that is a lot of line work that I then have to go erase. And I just don't want to do that. I'm too lazy, I don't want to erase all of it. Now, once you get the front two faces established, then you switch your vanishing points. So on this side, if we call these like the left and right, we were projecting the left side towards the left vanishing point, we were doing the right towards the right vanishing point. Well, once I get those two faces established, then I flip-flop. So then I would make the right go towards the left, and I would make the left go towards the right. And so then I have this drawn as 2-point perspective, where they're getting closer and closer together, or they're getting kind of smaller as it gets further away from me as the person viewing it. You can also do what's called, like, I call it the street eye, but I guess you could also just call it like the normal eye, where things are just directly on the horizon line. So you're drawing your object and it is in line with that horizon line. And so that's what I'll do for this shape as a perspective. Sorry, it's been an hour and 40 minutes. I'm sure you guys are zoning out, and I'm getting tired of hearing myself talk. So we're almost done. So the first thing I'm going to do is I'm going to establish kind of a front corner, and I'll bring these lines all the way over just so you can see them. And then I'll just draw a line all the way over towards vanishing point 1, draw a line all the way over to vanishing point 1. Same thing over here for my right side, is I'm just playing a game of connect the dots, essentially. And so this corner right here is the same as this corner on my object, or that edge on my object, rather. Then I would establish a depth on both sides, so I'll say that this one goes over to here, and I'll say this one goes about to here. It's probably too short, but what the heck. And so now I have my two sides created. With this kind of street eye view or human eye view, I'm not seeing either the bottom or the top, so I don't have to put any of those details in, but I still need to figure out where this piece would be sitting. So one thing to keep in mind is it wouldn't be split evenly necessarily, because since this side of the object is closer to us, this is going to appear a little bit bigger than on this side. So I want to make sure that this edge is just a little bit larger than this one. Then I'm going to go down to find where I would want those two to meet, and I would say, sure, I want it to go down that far. And it's still just a game of connect the dots. Now, with this edge that I have traveling back, I'm going to bring that one towards vanishing point 2. So because I can't see the top necessarily, doesn't mean that I'm still not following vanishing points, because that then would be going in my opposite direction. It would be the line flipping towards the back. And so there would then be this object, same object, just drawn as a 2-point perspective. To show it to you just real quickly is if I had it as like a bird's eye or a worm's eye. I'll erase. You know what? I'll do it as a bird's eye. Very indecisive. And I probably drew that way too hard on the page to actually erase it. Just because we'll be able to see that interior detail. And so also I'm going to skew this one closer to like vanishing point 2, just so you can see kind of how that manipulates it a little bit. And so I'll start with just a vertical corner, project towards, pick an established depth, project towards, pick an established depth, and now I'm going to flip the order that I draw these in. So I'm going to go vanishing point 1, and then I'm going to take my left one to my right side, so I'm now just flip-flopping. And so I've got an overall bounding box now for my object, just like with the isometric, just like with the obliques, just like even with the orthographic. I'm just always am starting with just an overall bounding box. And then I can decide what I want, like my depth to be, or what any other little detail features that I might have. So it's always, always, always starting with, let's see, that's about middle. So it's always, for me, the easiest way is always starting with a overall box and then just kind of carving your way out. And then let's bring that guy just back as a tracing point. And so start with that box, carve your way out. Start with the box, carve your way out. That is the method that I find the easiest and friendliest to work with and understand. And really, all drafting is just series of lines and arcs and just putting them in different places. And once you start getting the hang of it, and I understand too that you are not going to get the hang of it in one single day of exercises. You are not going to get the hang of making these by doing 4 drawings and become the master draftsman, and that's just fine. And then frankly, that's what I expect out of you guys. I don't want you to become perfect at it right away. The more we practice, the better we get. But that's just kind of how you would lay out the 4 different types of drawings. Your next part of this kind of assignment is to take something that you have in your home and create, and they can be free-done sketches, so it can be like these boxes I did, where they definitely are not perfect. I didn't use any tools to draw them. You can lay out the orthographic without using any tools as well. So you can just kind of freehand draw your orthographics out too if you need to, but maybe do a little bit better symmetry than that. Geez, Dinah. But you're going to create an orthographic, an isometric, either an oblique or either a plan or elevation oblique, and a perspective. So 4 different drawings based on an object that you have in your house. And I recommend you try to take something and challenge yourself a little bit with it. So don't go too overboard. Don't like take the most complicated thing you own and try to create all the different views of it. But, and the example I put on the worksheet is, don't like take the sponge out of your kitchen sink. Don't like take your brand new eraser that you bought and just give me a box 4 times. Try to take something that maybe has like a curve to it or some angles to it and create the 4 different views of it. Other than that, I think that's it for me, and if not, it's purely because I've now been talking for 2 hours and have lost my train of thought. So if there's anything else, I'll be sure to include it on the worksheet or in an email to you guys. But thanks for sticking around. Email me with questions, and I'll see you guys in the next one.